on it. All right, let us look at our second tutorial question for today. The question says, the weight of 100 grams hangs from a lever 20 centimeters to the right of the pivot. At the left side, this is supposed to be, at the left side is a 500 weight 20 centimeters from the pivot and a 200 grams weight x centimeters away from the pivot. What is the value of x on it? All right, let us look at our second tutorial question for today. The question says, the weight of 100 grams hangs from a lever 20 centimeters to the right of the pivot. At the left side, this is supposed to be, at the left side is a 500 weight 20 centimeters from the pivot and a 200 grams weight x centimeters away from the pivot. What is the value of x? Right? The value of x has to be in centimeters. What is the value of x that makes the liver balance? The value of x that makes the liver balance. Now, this problem is taken from the principle of moment. And for you to be able to solve a problem, you should be able to sketch the statement of the question. All right, you put it in a diagrammatic form, the way it will give you the position of the lever, the weights that were given, and so on and so forth, which is what we are going to do a representation on. So we come here, we say assume that the lever is uniform. All right. If the lever is not uniform, it may present a different case. But if we assume that the lever is uniform, and then we try to draw, you can pause. This is the representation, right? This is the pivot. And then they say to the right of the pivot, we have a weight of 1,000 centimeters, 1,000 grams, 20 centimeters away from the pivot. And then we have a weight of 500 grams, okay, which is 20 centimeters away from the pivot. Then they told us that a weight of 200 grams is x centimeters away from the pivot, right? So if we do all of this, the distance between 500 grams and 200 grams, since from pivot to the line of action of the 200 grams is x centimeters, then we can have the short distance between 500 grams and 200 grams to be x minus 20, because from here to here is 20. So what remains from here to here will be the distance from the pivot to the line of action of the 200 grams x minus 20. Now, when you have explicitly done this sort of beautiful representation, it becomes very easier for you to take the moment of the forces. So, to be able to take the moment of this force, all right, you put your finger into the page and then you move. When you come to the line of action of this 1,000 grams, you bend towards where you are coming from, then you begin to turn. All right, so if you are turning like this is a sign that it is an anti-clockwise moment. All right, the same way, you put your finger into the pitch, then you move through the distance and follow the line of action of this force of 500 grams or weight. So you bend towards where you are coming from, you begin to turn. Now, when you are turning, this one is clockwise moment. The same thing also happens. We trace if a line of action of 200 grams, and then we bend towards where we are coming from, we begin to turn. This also gives us clockwise moment. So we know the moments that are clockwise, and then we know the moments that are anti-clockwise. Okay? So This is the only one that is anti-clockwise. We have clockwise moment, we have clockwise moment. So we say that the sum of clockwise moment is equal to of the sum of anti-clockwise moment is equal to the sum of clockwise moment. So what we have is 1000 times 20 equals, we have um, 500 times 20 plus we have okay, we can have 200 times x, right? We have 200 times x. So what we are going to do here, if we do this multiplication, this is going to give us 20,000. And if we do this, this is going to give us 10,000. It's going to give us 10,000. Then we have 200 times x. So if we bring this one here, um, we'll have 20,000 minus 10,000. All right, that's going to give us 200x. So we now say, therefore, our 200x is equal to 10,000, meaning that our x is equal to 10,000 divided by 200, and that's going to give us 50, 50 centimeters. So this will be the value of x that must exist in this equilibrium to be able to make it stable. I hope you learned something, especially in the instances where we took the moments about the line of action of the forces, right? Note, this is a point of inclination known as either fulcrum or pivot. Please, we need your signing. Want you to put a comment there. Let us know what your opinions are. Thank you.